warm-up problems. We're going to walk through those because we got out of quadratics and now we're getting into imaginary numbers, and we have to start looking at things like adding and subtracting and then also multiplying complex numbers. Okay, so the first problem that we have up here, number 1, we're looking for addition problems here. Okay, we're all adding these problems. My first thing that I would do would be to identify all the like terms, right? Combine like terms after. So identify the like terms and then we'll CLT, we'll combine them. Make sure we're taking plenty of note up here to include the negatives. -8, mark it, plus, what do we have? 6 plus 7. Okay, those are all our normal numbers, our real numbers. Now we'll take a look at the imaginary side of these equations. And notice right here, I'm putting in a plus, and I'll explain that here in a minute, because we want things in our standard form, and we'll look at that. So now we'll take a look and combine all of our imaginary like terms. 6x plus a -6x. Don't be afraid to put parentheses around it too, so we don't get these two confused. Then we will add our 6i as well, and once we're there, thank you very much, we'll just combine the like terms. So we identify our individual parts, sequester them, and then combine like terms. What do we end up having over here? -8 plus 6 plus 7 gives us what? 5. There we go. 5 plus, here we go, I got a 6i that crosses out with a -6i, and we're left with 6i. Perfect. Square it off so we know what we're doing with our answer. We got lucky on this problem that there was only basically one step. Okay? Question?
How did the positive and the -6i cancel each other?
Positive 6i minus 6i, right?
Oh.
Plus 6 minus 6, right? That's why we made note to highlight our negatives on this. Okay? Negatives is the biggest issue when we're adding and subtracting these complex numbers. That's where everybody makes the mistakes. Okay? Let's take a look at number 2 over here. We'll identify the like terms and then we'll look to combine them. 3 minus 5, right? And let's highlight what we're doing with this. We're subtracting away. 3 minus 5, we're still putting the plus in between. Why? Because of our standard form at the end, right? So now we'll take our -4i. Don't forget to include that negative again. Some of us already messed up on 1, not including the negative. And it's -4 minus 7i. Okay? In between the two terms themselves is a plus because we want them all in standard form to start. But we're subtracting away that 7i. So here we are, we're left with -2 plus still for our standard form, -11i. Now we can simplify that, obviously, -2, -11i, and we'll still square it off so we know what we're doing. Okay, we don't want it to get confused in with all the other simplifications that we've made. Okay, I'm not sure how many of you guys got to number 3, or if we were able to really identify what we were doing here. We have a 5i times what would be a -1i. Don't forget that this is technically a -1 in there. Okay? Now we're going to look to combine our terms. We have a -1 times a 5 and an I times an I. Now all of this is times itself too. So we end up with a -5i squared, right? Are we done with this? We briefly learned that I squared is related to -1. So we can substitute out our I squared and get -5 times -1, which gives us just 5 for an answer. Okay? Everybody following along? Any questions on some of the addition and subtraction? All right. So let's take a look now at how we even got to I in complex numbers. Okay? Right? Now we're dealing with them, but why are we here? And then where are we going to be going from there? So biggest thing that we did last unit here was the quadratic formula and quadratic form, right? We have ax squared plus bx plus c equals 0. Okay, now all that's fine and good because we can normally factor and find things like that from that standard form. Our quadratic formula, right, as we remember here, x equals negative b plus or minus b squared minus 4ac, the long one, all over 2a. Now I'm going to spare you guys the math at how we get from our quadratic form to the quadratic formula, but it involves, and tell me if this sounds familiar, completing the square. Right? Did we learn about that in quadratics? We can factor, we can complete the square, we can do a couple different things in order to solve. But this is essentially the equation for x when we complete the square over here. So I'll kind of spare you that difference. We'll go into that at the higher levels of math. So here's how we're getting to our quadratic formula. This is the key right here. Inside of here, inside of the radical, when we have a positive result, it equals two real numbers. Okay? When it's a 0 in there, we only have one solution. Okay? And that makes sense because our solution then is negative b over 2a. Right? This whole thing equals 0. So our solution is negative b over 2a. Does anyone know what that kind of looks like? Axis of symmetry, right? Which makes sense. If we only have one solution, it's along our straight line axis of symmetry, or if it goes horizontal, a straight line axis of symmetry. There'll only be one point on those dots, okay? And if we get a negative number inside our radical there, we get a pair of complex numbers, which is kind of where we're at now with complex numbers that we're getting into. But how did we figure out what I is and where it went into? Well, we have this little conundrum in math that we've come across. X squared plus 1 equals 0. Well, how is that possible? Okay, x squared equals negative 1. We would then take the square root of both sides to get our x, and x is the square root of negative 1. Okay? Now we can check our answer on there, right? It pretty much means x equals a positive or negative I unit. Okay? And we'll go ahead and check that out by inserting I back into our equations. We've talked about substituting before. In a few of our earlier classes for IM1, we'll substitute as well. X squared plus 1 equals 0. We're going to substitute in this positive or negative I. So regular I squared plus 1 equals 0, and negative I squared plus 1 equals 0. Well, we've talked about I squared before. I squared is negative 1 plus 1 equals 0. Negative I squared would be negative 1, or excuse me, negative I times negative I plus 1. These end up giving us what? A positive I squared again, which is still what we talked about, negative 1 plus or 1 equals 0. So both of these things end up checking out. That's how we end up getting to complex and imaginary numbers. What are our real-world uses for this? We've already talked about two of them. Quadratics. And what else? Complex numbers. There's a third one that's really the only other time that we see it out of these math classes. We have sine waves in electricity. These alternate between negative and positive currents, right? That's our plus or our minus I that we're getting. So we see it in electricity, in complex numbers, and in quadratics. Okay? Other than that, the applications get into other more complex subjects. Okay? And we won't ever work with anything dealing with electricity in here, You probably won't see much of that until the college level. So let's take a look here. I've also included some notes over on the board over there that are color coded if for some reason I'm going too fast. But we need to think about the commutative, associative, and distributive properties when we're adding and multiplying, complex numbers. The commutative property, right, and I'll just write COMM up here, A plus B equals B plus A. Same thing happens with A times B and B times A, right? We can switch those out. They can communicate between each other. You can switch these two positions, okay? On that chart, I have such and such property, addition or multiplication. What I really didn't include is the actual verbiage of all that. This is the commutative property of one of those two, so we should have put it out in the full sentence there. Associative, okay, associative A plus B plus C can also be A plus B plus C. It can move right around on there. We also have a multiplicative property of association. Bear with my voice here, guys. Sorry about that. A times B times C. Okay? And our last one, the distributive property, is what we're going to end up using the most. A times our B plus C can also be A times B plus A times C. Okay? So that's a brief review of what we're working with. Now also on the far left over there it says no, right? I didn't go into explaining that, but those are the properties that don't work for commutative and associative. A minus B is different than B minus A. If you have 2 minus 5, we have negative 3. If you have 5 minus 2, it's now a positive 3. So those are the types of mathematics or arithmetic that don't work for those properties. Mostly subtraction and division. So, we're on to kind of a different part here. Let's take a look at our homework worksheets. And Marlon, I think you had one question for me that we were going to look at first.
Yeah, 3 plus 2i, and then plus 4 minus 5i.
Plus 4 minus 5i. Perfect. So let's take a look at this now. As far as our commutative properties, associative properties, and distributive properties, we're dealing with addition up here. Okay? We're going to look to combine like